Good afternoon, good evening, or good morning from wherever you are joining us from today. Welcome to a Microsoft Reactor live stream event. My name is Kaylee, and I'm the event planner for the Redmond Reactor space. Before we kick off the session, I have some housekeeping rules I'd like to run through. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and please remain professional and on topic. This session will run for about 60 minutes. If you would like to refer back to today's session, you can do so on our Reactor YouTube channel after today's live stream. Please submit your questions through the chat and we will try to answer as many as possible. Additional learning links will be added to the chat during the session. It is now time to begin the session, so I will hand it over to Jay Gordon.
Hey everybody, my name is Jay Gordon. Welcome back to the Azure Cosmos DB global user group, where we meet up just about once a month and we try to give you some great information about how Azure Cosmos DB fits into your application. And so we get great community people to be part of this. We get people from Microsoft. We just want to learn a little bit more about Azure Cosmos DB and its implementation from talking to a variety of people. I will give you an introduction to our guest today, but before we do, I got a little bit of housekeeping to go through. First of all, the Azure Cosmos DB Conf call for papers is open. I will put this in the chat. Please head on over, submit your idea to the conference. We want to hear from you. We really, really would love you to be part. The next thing that I want to mention is we are brought to you in partnership with the Microsoft Reactor. If you'd like more information about Reactor events, including future global user groups, please head on over. I think we've got just one more thing, and that is, hey, if you want to try Azure Cosmos DB for free, please go to aka.ms/trycosmosdb. You will get a no credit card required account for you to get started understanding how it works. You can do it for all the different APIs that we have available. I think you're going to learn a lot. So I'll put some of these links in the chat, but now I believe it's time to go ahead and add my guest into our chat here. And so I want to introduce you all to David Poulet. Hi, David. How are you?
Hi, Jay. I'm great. Thanks. How are things?
Good, good. So you come to us from, if I'm right, our global black belt team. Is that correct?
That's right. Yeah.
And before you explain what that is, I'd love to learn a little bit more about yourself, because we're going to be talking about some really, really important topics. How high availability and resiliency fits into the story of building applications with Cosmos DB. So why don't you tell me a little bit about, how you got here, I think is the best way to put it.
Sure. So I've been working in IT for quite a long time now, but I started out in development. So way back when I was a Unix developer, developing in C, and I moved into the Java world. So I spent a long time developing applications in Java across a whole bunch of different verticals, but sort of typically, these were things that involve large quantities of data, right, and data moving at high speed. And after doing that for quite a few years, I started to move more towards kind of, focusing, if you like, on that kind of, I suppose, data movement sort of piece, really.
Sure.
And ended up drifting into the Hadoop world, which was a big thing, still is a big thing, I guess. And I was working, writing big applications in Spark and Scala and so on at the point when I joined Microsoft. I guess you could probably consider me not maybe a traditional Microsoft employee, certainly at that time, because my background was Unix and open source and Java and so on. But since that time, in Microsoft, I've been focusing on everything related to building modern applications and modern powerful data platforms in Azure. So I spent a couple of years as a data and AI CSA. So it's a cloud solution architect that focuses on the data and AI side. Mm-hmm. And I've also spent a couple of years app dev focus, so focusing on cloud native developer platforms and AKS and that kind of thing. But more recently, for the last couple of years, I've moved into the global black belt team, focusing on NoSQL. So the global black belt team, as the name suggests, we're like a global team. We cover customers all around the world, but we tend to focus on kind of more narrower, like specific areas of tech, right? So, and the area that I focus on is NoSQL, and in particular, that's Azure Cosmos DB.
Great. And if I'm right, there are lots and lots of those global black belts stationed around the world to help people get the most, build the best, and really understand how these products around Azure, whether it's like you mentioned, AKS or something like that, or Azure Cosmos DB, how they all fit together. So having some people with some expertise definitely can help you kind of get more comfortable with the platform.
Yeah, that's right. And I think the thing is that, the role of the global black belt, the GBB, as we call it, is to provide that really deep expertise. And because you're doing it, over and over again, I've had a lot of experience now over the last 2 years of working with Azure Cosmos DB with the biggest customers in the world. So, I can't think of many things I've not seen, put it that way, on Cosmos DB.
Great. So speaking of Cosmos DB, and let's talk a little bit about what you're here for today, which is discussing resiliency, high availability, and how it all fits into your Azure Cosmos DB account.
Yeah, so I'm going to talk about high availability is a really big topic, and it's a key reason why a lot of people choose Cosmos DB, because it's out of the box, it's designed to make that as simple as possible. So if it's okay, Jay, I'm going to share some slides.
Sure.
And do that. And what we'll hopefully do, time allowing, is I'll actually show it in action.
Great. So go ahead and why don't you share the presentation in our handy dandy platform. And while you're doing that, we've got some great documentation that you can check around building resilient applications for Cosmos DB. So you can check out this URL. And we've also got another great one, which is designing, or I should say, achieve high availability with Azure Cosmos DB. So we've got these app URLs ready for you to go. I will put them in the chat as well. So David, I'm going to bring up your presentation and I'm going to let you roll into it. Sound good?
Sounds good. Okay, so I want to start out by just kind of narrowing down the conversation in terms of what we mean when we talk about high availability, right? Because there are a lot of things that you can do when you're designing a system that look at failure. Basically, they're thinking about what happens if stuff goes wrong, and that can cover a whole range of things, from the sort of things we're going to talk about today, which is high availability, right the way through to kind of disaster recovery and backups and restores and stuff like that. I'm going to focus specifically about availability, and what we mean when we're talking about availability is kind of a basic thing that most people want from a system, that it is there doing what it is supposed to do when we need it to do that thing, right? But there are times when things go wrong, and the key to providing like the best experience for the customer or the best experience for your users, whoever they may be, is designing the system in such a way that it recovers from those mishaps, right? And that's what we're going to talk about in the rest of this presentation. Okay, so first thing I want to talk about with Cosmos DB is about replication, okay, in region, okay. So when you first go out and you stand up a Cosmos DB instance, you go into the portal, I want Azure Cosmos DB, you pick your API, et cetera, and you pick a region that instance is going to be deployed into, and that's your primary region, okay. And one of the key things about Cosmos DB is we manage away as much as possible, the kind of legwork that you have to do to make the data resilient and have it replicated within that region. And so it happens by default, right? When you first create a Cosmos DB instance and you push data into that instance, in the back end, there's servers and there's compute and there's disks, and your data is replicated. And it's replicated at least 4 times, right? So there's a primary and 3 replicas at a minimum of your data within any region that Cosmos DB exists in. The great thing about Cosmos is that you don't have to manage that in terms of, like a lot of databases. You've got to decide how you're going to do the replication. You're going to have to decide how many VMs or whatever you're going to have in order to make that happen. And so one of the key things that we have with Cosmos is that as much of that kind of implementation detail and management detail is managed away and taken care of for you. So you can worry about kind of the most important things, really. It's worth noting as well, so you get that replication by default, within a region. Your data exists in multiple places, and we maintain those, but also you've got the ability to add availability zones. So for people who aren't familiar with availability zones, if you imagine within a data center, you have racks and racks of servers, and you've got the disks and so on, and they're sitting there. But you also, within a region, within Azure region, you have multiple data centers, right, that are closely linked together and linked with high-speed networking. And an availability zone is this concept that you can have a zone which is one building, if you like, and then there's another zone which is physically separated from that one, typically in another building or whatever. So for additional kind of resilience, you can ask Azure Cosmos DB to replicate your data across availability zones, and that's something that you can add. It doesn't happen by default, but it's something you can add if you want that to be there to give that sort of extra resilience. So the primary thing I want to take away from this is when you first actually put Cosmos DB in a region and you start working with it, you have a high level of resilience already within that region. Okay, and because we manage it for you, you don't have to worry about managing servers and patching servers and so on. And the way that replication happens means that when things happen in the back end, like we need to also patch servers and so on, it doesn't impact the performance or the availability of that system at all. Okay, but I think beyond that, for a lot of people, what's key is this idea of geo-distribution, which is, okay, so I've got my data replicated within the region. I've got multiple copies of my data. That's cool. But I also want to add on to that, the peace of mind, if you like, that means I've got data in other regions as well. And this is kind of what we call geo-replication. Again, like in Azure Cosmos DB, I think it's another kind of key aspect of the platform is this is designed to be as simple as possible. It's not always simple. In fact, sometimes it's very complex in many other database systems to actually start to replicate your data over to another geographical region, to maintain that replication so that it's in step, and also to configure applications so that they can take advantage of that. And so with Cosmos DB, what we try and do is to make that as simple as possible. There's kind of a screenshot here from what the screen looks like, but it really is as simple as, once you've got you stood up your primary region, you can go in and just pick locations on the map and say, okay, I want to replicate to those other regions. You click save, and the system immediately starts to replicate data. Okay, and that's it. That's all there is to it, really. And then from that point onwards, whenever things are, whenever writes or updates happen in your primary region, then those writes and updates are replicated automatically into the secondary regions. So there's a couple of different concepts in here, and I'm going to go through what we mean when we mean these two different things. So we have the concept of single write master and multi-write master, okay, or single write region and multi-write region. They're used interchangeably. So I want to go into a little bit of detail, so we understand what we mean when we talk about these two concepts. So let's take a look at what a single write master means. So this kind of slightly complex diagram shows you that in green there, right? That's my primary region. That's my write region, and I have a single write region. Okay, so that means that writes can only go to that region. And you'll see the two applications here. They in this case is an application in region 1 and A and B. Could be anywhere really. they're both writing, that's in red, they're both writing to that primary write region, because that is the only write region, right? But the data is being replicated all the time to the secondary region, what we call the read region in region B. So an application can read from either region, right? So an application in region A might read from the one in region A. An application from region B can read from region B. And also the two applications can read from Cosmos databases that are in other regions, right? So an application in region A can also read from region B. But the key thing to take away is that you have one write region, but multiple read regions, and the data is kept in sync automatically, okay? And the reason I've mentioned it here in this diagram, failure modes, is, as we'll see later on, and we'll hopefully see in the demo, is that one of the key things about Cosmos DB is that the SDKs understand the concept of different regions, and they're able to actually start to reach across to other regions when failures are happening. But we'll see that in more detail later on. Right? Now, when we talk about multi-write master, this is where we've got all of our regions, or multiple regions, are writable at the same time. So applications can both read and write to multiple regions, and the replication in that instance is happening. In this case, it's bi-directional, right? But it could happen across multiple directions. But the idea is that obviously, if you've got multiple write regions, then writes and updates have to move between the regions, and so that there's quite a complex architecture there going on that's flowing the writes in constantly between all those regions. And so those are the two types, if you like, of geo-replication that we have. We have single write region and multiple read regions, or we have multiple write regions.
David, can I
Yes.
bring up a question from one of our viewers?
I will go back, yes.
Sure. So Jack wants to know, what is the lag for replication, say from a primary in New York City to a replica in, say, Sydney?
Okay, so I mean, it varies. There is a table on in the documentation, and I don't have it to hand. I can't memorize the URL, but there is a continuously updated kind of documentation page that shows you what the typical latencies are between all the regions in Azure, and it'll give you like average latency and so on, so that you can see what we're running at the moment. So, I mean, just kind of ballpark figures. If you're looking at two very close regions together, like for instance, I'm based in Europe, so for instance, UK South and UK West, the two European regions, the latency there is going to be in the region of sort of single-digit milliseconds, or maybe 10, 15 milliseconds, something like that. But obviously, as you get to further distance that become thousands of miles away, then that latency can increase. And that's something that you do have to think about. But as we'll see when we look at the consistency slides, if you must have data that's, say, written in region A, if you must guarantee that it's in region B before anything else happens, then you can actually achieve that with the consistency settings.
Great. Thank you so much, David. Why don't you go ahead and continue? And if we get more questions, I will go ahead and let you know.
Sure. Great. So, I mean, that brings us nicely onto consistency, right? So I'm going to, consistency is a complex topic that we could easily spend an hour just talking about. But the key thing here is that the Cosmos DB gives you these five different consistencies that you can select, okay, from strong consistency right the way up to eventual consistency. Without going into too much detail, like strong consistency gives you the behavior that a lot of people like to see and often expect to see in more traditional, like, relational databases. And to simplify it, sort of really grossly, strong consistency is this idea that when I update or when I change anything in the database, right, create a new item or update an item, delete an item, that I guarantee that the next operation on that item, wherever it comes from, will see that change. Okay, and that's what we call strong consistency. And as you go, towards the to the right there, and you go through the different levels of consistency, all the way over to eventual consistency, we've got different kind of characteristics of the consistency. But obviously, over at eventual, when you get all the way over eventual, you've got a situation which is kind of the polar opposite of strong, which is when I update or I change something in the database, there's no guarantee that the next operation on that item will see that change. we guarantee that it will happen eventually. We do have an SLA for that, but it's certainly not immediate, right? And depending on how you want your application to behave, you can set your settings between these 5 settings, and they can give you variations. Like, for instance, I want things to be guaranteed to be consistent within a certain time frame, for instance, or I want things to be definitely consistent, strongly consistent in region A, but I don't care if maybe it takes a little bit longer to get to region B. And you've got all these kind of different levers that you can pull together. And it's another topic I want to talk about, which is related to this consistency setting, because all these things feed into this idea of, like, how do I design a highly available system? You have questions to ask yourself of what high availability means and what you need out of your system, right? And so another topic is about RTO and RPO. And as we'll see, the consistency level and the replication, the geo-replication, and the RTO and RPO considerations all come together in your design decisions. So just to kind of like a quick refresher for people who can't remember what the terms mean. So we talk about RTO, we're talking about recovery time objective. And again, I've really simplified the definition here, but for me, recovery time objective is how much time does it take after there's been a failure for my database to get back to the way I want it to be? And that applies to the whole application, of course, as well. How much time, basically, is this application going to be down before it starts working again? And the recovery point objective is often very specific to databases. It's about how much data we're prepared to lose during that process. And it's kind of like, there are trade-offs in there, because you may be quite happy for your system to be down for 15 minutes or 30 minutes, but you definitely do not want to lose any data. And we see that quite commonly in things like systems of record and financial transactions and stuff. There's no way we want to lose any data there. But there are plenty of systems where we can stand to maybe lose a little bit of data, where it's more important for us to have that zero RTO. The system has to be up all the time. And then there's like trade-offs in between. Okay. And so I'm going to give you some examples here. This is by no means every potential combination of these, but these are 3 common examples of the kinds of trade-offs that we're going to get when we're looking at RTO and RPO in our Cosmos DB database that is now replicated across multiple regions, right? So for instance, if we start from the top, and I know this is quite a complex slide, but we've got this concept of multi-region, but single write master, okay? So I'm writing to one region, but the data is being replicated over to that secondary region, okay, for high availability. And here it's possible to get an RPO of 0 with strong consistency, because with strong consistency, what we're saying, and even in a multi-region scenario, right, what we're saying is when I write or update something to my write region, I guarantee that that update is going to be in all my secondary regions at the point when that write completes. So I issue a write operation. The application gets back, okay, write operation has completed. With strong consistency, we guarantee that all those that write now exists in all of the secondary regions. And that gives us an RPO of 0. Because if I lose that primary region, and as we'll see in a little bit further down the slides and in the demo, if I lose that primary write region and I fail over to my secondary region, all the changes that I've made will be there. So recovery point objective 0, I haven't lost any data. However, in that scenario, because of the way that we architect things at Cosmos DB, when we have a single write master, it takes some time to fail over, as we'll see in a minute. And so that RTO is up to 15 minutes. And I'll talk a little bit about that when I talk about failover in very shortly. So it takes a little while to get the system back together. But when we're talking about multi-write regions, where we can write to all our regions, and we can read from all our regions, then in the second example there, it's possible then to have an RTO, a recovery time objective of 0, because there's always a region available that we can both read and write to, which means we can always do the work that we need to do, even if we lose a region. However, it's not possible in Cosmos DB to have strong consistency and multi-write regions. The strongest level of consistency that we offer is called bounded staleness, and that gives us a recovery point objective of up to 5 minutes, right? That's the SLA. Okay, so there's a trade-off there with the potential for data loss if you're in multi-write mode. And then if we take the bottom example is just more, is our session consistency. That's the default consistency that you get when you stand up a Cosmos DB database. They're on a multi-write mode. Again, you still got the possibility of RTO 0. You can flip quite quickly to another region and lose no time at all in your application. But the recovery point objective, the kind of potential for data loss, is longer with session consistency. Now, bear in mind that these numbers that I've given you, like for the recovery point objective, the data loss potential, 5 minutes, 15 minutes, these are SLA-backed guarantees, right? So we guarantee that. Now, obviously, the SLAs exists to cover any scenario of Cosmos DB at all. Like, you could have databases with, and we do have databases, petabytes of data in there. And that SLA is there to guarantee that even if you're, running with 5 or 6 petabytes of data, that you will meet that objective. And even if you're running with, hundreds of thousands potentially of transactions a second or whatever it might be, we'll meet that objective. So that's an SLA guarantee, but in reality, the time will be shorter than that for most people, because most people's databases are not petabytes of data and not hundreds of thousands of transactions a second. So that's why we say it could be up to 5 minutes or up to 15 minutes. Okay, I'm going to talk about that failover mode in more detail. Before I do that, I just wanted to talk about something else that's important when you're architecting systems for high availability. Just to remember that all this kind of config we're talking about, geo-replication and consistency defaults and things like that, they all happen at the account level. Okay, so when you stand up a Cosmos DB instance, you're creating a Cosmos DB account, and then you create databases and containers and what have you underneath that. The reason why I wanted to point this out, because if you decide that you want to geo-replicate across multiple regions, everything in the account is going to be replicated. And this is important because a lot of times when customers are, they're building platforms, they don't want to replicate everything. There might be a critical production system that needs to be geo-replicated, that needs strong consistency. But there are other systems that don't need to be geo-replicated or don't need strong consistency. And so for those, they would need to be in separate accounts. Because otherwise what happens is, and it does sometimes happen where someone will stand up a Cosmos DB account and they'll put in a production database and they'll put in dev databases and test databases all in that account. And everything they have is replicated to all the other regions, which obviously has some kind of sizing and cost implications if you do that. So worth remembering that when you're thinking about how you design, your account strategy, basically. Okay, so we've talked about all the various parts of the system that come together to give us high availability. We've talked about, geo-replication and whether it's single or multi-write master. We've talked about the consistency level that we might want to set. We've talked about various things. So let's have a think about what happens when we have an outage, right? When something happens that's going to impact our Cosmos DB database. And there are different failure modes, and this is kind of a really key distinction to make. Okay. We have the concept of a region outage, which is all of the Cosmos DB instances in a region are unavailable. Okay. For whatever reason, there's been some region-wide failure, and that triggers a certain kind of behavior, as we'll see in a moment, right? That's different from what I call service unavailability, which means your Cosmos DB account for some reason is not available. It could be a whole range of different reasons, right? It could be a region. It could be a reason that's happening, in the back end. There's something that's happening within that Azure region. It could be something that's happening between your application and that back end. But for some reason, you can't access that Cosmos DB. So these are two different failure modes, right? And they impact a number of different things, as we'll see. I wanted to point out a couple of different things, which is of note here, because we're going to talk about it. We do have some ability to control the behavior during outages. And I'm just pointing them out here. We have this manual failover and service managed failover. Okay, now I wanted to sort of keep those terms in your mind because we're going to see those in operation in a little bit. Okay, so when you have a region outage, that this is what we talk about, we know I mentioned that the region outage is the whole of a region goes out. This triggers some automated behavior, right? And we call this service managed failover. Okay, so going back briefly to there, this is an option that you can take when you're configuring your geo-replication. So a region goes out. Microsoft detects that region is not available, and we do a certain kind of behavior takes place as a result of that, right? So in this example here, I'm going to step you through it. It's for a single write master scenario. So this is probably the most common type of scenario we have, where somebody has maybe multiple regions. One of them is the write region, the other is a read region. And this is what's going on here. Okay, so this is the diagram shows this. So writes are happening to region A, which is our primary, our write region. Reads are maybe going to region A and region B, and the applications are merely sort of like going to the regions that are appropriate. And the two regions are replicating from one to the other, right? The write region is replicating to the other region. And let's say we have like some kind of failure scenario, right? What we call a region outage. Remember, this is the key thing, a region outage scenario. So what happens in the back end is that when that region outage is detected, that region is marked offline, right? And the failover process starts to begin. And there's a certain amount of time that this takes. And if you recall, we have that SLA, that RTO, that recovery time objective of 15 minutes. And that's because that's the maximum amount of time that this process can take, right? So a region outage is detected, the failover process starts. The first step is that in the back end, that region is marked offline, right, in the back end. The SDKs automatically detect that region is offline, that your primary region, don't forget this is, the region A, is offline, and they start to redirect their operations to the secondary region. We'll see a little bit more about that in the demo. Now bear in mind that we're still failing over at this point. So the back end stuff is still happening in the back end, and although reads will probably succeed immediately afterwards because the read is in sync and everything is fine, there may be a period where writes are not available while we're doing the failover. Now, once the failover is complete, what happens is that region, a secondary region, is promoted, and it becomes the primary region. It becomes the write region, right? And at this point, we're all good to go. The two applications endpoints, the applications have already migrated over, so they've already in position to take advantage of this. But what we have now is because the failover is complete and region B has been promoted, the writes will also succeed. Okay, so everything is good to go. And it's worth noting that we've talked about a single write region, slightly different in a multi-master scenario because we don't have to do any promotions in the multi-write master scenario because all of the regions can be written to anyway. So as soon as the region is marked offline, or one of the regions is marked offline, any application, endpoints that are pointing to our account, they'll detect very quickly, very rapidly that's happened, and the SDKs will move you will start talking to other regions, okay? And the reason, by the way, that the SDKs are able to do this is because they kind of chat fairly continuously to the global endpoint and get metadata back about the system. But going back to the slide, in a multi-write master scenario, we don't have the time lag of the failover because we already have other regions ready to go to take over writes as well as reads. And worth noting that once that failed region is back online, then replication restarts back from your sort of your primary write region over to that secondary region. We don't fail back, right? In terms of flipping the regions over necessarily. You have an option in how you want to do that. Okay, so that was region outage, right? Remember that's where an entire region goes out. But most kind of failure modes are not outages, right? They're not full outages. They are they're various unavailability reasons, where you can't get to your Cosmos DB endpoint. And like I said, a lot of different reasons that could be. Could be something that's happening in the back end that means that Cosmos DB database is having a problem, or potentially a single partition, a single node is having a problem, whatever it might be. Or it could be something in between, like some kind of network failure or whatever. I'm going to summarize there's various things in this slide, but obviously when we're talking about unavailability, then there's lots of different ways that this can manifest itself. It could be just occasional errors, right? These transient errors. It could be transient errors that do repeat on a regular basis, so that you're getting them regularly all the time, or it could be like total failures, like everything in a particular region just isn't working. And obviously, as application designers, you need to be able to detect these types of errors for a start. And then secondly, you need to understand how to react to those things. And that's something we'll come back to in terms of kind of the way that we think about designing like highly available applications, is that sometimes we can take the mindset that failure is just a kind of either or sort of thing, right? It's either everything fails or everything works. But more typically what happens is you'll get partial failures or transient failures. So that they're happening sometimes, but not all the time. So if you want an application that performs in a way that you can predict and that gives predictable performance, you kind of need to be on top of everything that's going on in your system to detect these types of failure, whatever they might be. Okay, and this was the main challenge that I wanted to why I want to highlight the difference, right, between the region outage that we talked about before, that has automatic failover, and then just various kinds of service problem where we don't failover, right? That service managed failover, that automated failover of a region from one to another only happens during a region outage. We don't automatically fail over instances if it's a partial outage within that region, which means that in order to manage partial failures, for instance, maybe just if you've got a bunch of Cosmos DB instances or accounts, and one of them seems to be having issues, then it's kind of down to you as application designers to figure out how you're going to deal with that, because we're not going to automatically fail over in that instance. And the monitoring and observability is what's key, right? This is the kind of the critical thing that you have to think about when you're designing these highly available systems, is bearing in mind that a certain amount of automated mitigation will happen. And we'll talk about the different ways that the SDK does that in a minute. You still have to know what's going on in your system. And you do that through application insights, right? Or Azure Monitor or whatever it might be. And what you're looking for is things like, what's my average latency? Am I getting latency spikes? Am I getting a gradual decrease in performance in terms of throughput? Am I getting a gradual decrease or increase, if you like, in latency? And also, am I getting kind of like exceptions surface maybe in App Insights that are not fatal exceptions, but they're an indication that something is not right with the system. Availability issues will typically be, as I've mentioned on the slide, they actually surface as like 408 or 503 exceptions. The 408 exception, the 503 exceptions, they relate to things like timeouts or the SDK saying, I can't access an endpoint. And so between them, 408 and 503 cover the range of these types of errors. And typically what you'll see, and we'll see this in the demo, is that the SDK, if it's configured correctly, will automatically handle transient unavailability, but it'll still surface exceptions in the log to say that it's having to deal with that. Yeah. Okay, so one thing I wanted to point out is that when you've got a single write region, we did have, like, if I casting your minds back to a few slides back, I highlighted an option in the Geo-Replication page which said manual failover. So we do have the possibility to manually fail over a single write region. So remember that because we're not talking about a region outage, we're just talking about some other kind of availability issue. It doesn't automatically fail over. So if you want to reproduce the behavior of an automated failover, you can use the manual failover feature. You go into the portal, and it doesn't have to be done through the portal, but let's say you go through the portal, you hit manual failover, and it'll basically do the behavior that I showed before in a manual way, which is it'll mark that region offline. The SDKs will all be informed that, the active application endpoints, if you like, will be informed that region is offline. and it'll promote the secondary region and so on and so forth. And it'll go through that entire process that we talked about before, but it's triggered by you manually. Okay. And this is, you would normally only never need to do this if you've got some availability issue, which is not an entire region outage, right? But with multi-write region, we don't get that manual failover option, because the idea is that you have multiple regions and they're both writable and readable, and any one of those regions can be effectively kind of a primary region, if you like. And so the key thing when you've got multi-write regions is to make sure you design your application in such a way that it just continues on without any issues whatsoever, and will deal with any region outage scenario. Sorry, any region unavailability issue scenario. But again, going back to the monitoring, that you do need to, you want to know that this stuff is happening, right? So you do need to set up the logging and so on, so that and alerting as well, in particular, around that logging to trigger some kind of mitigation on your side, right? Even when the application is designed correctly so that it's able to deal with these kinds of situations with as minimal impact at all on the end users, you still want to know about it, right? So that you can figure out what you need to do kind of in the medium to long term about it. Okay, so, and this is where we're going to get into the SDK. I'm going to cover the SDK, and we should just have then a little bit of time to cut to a demo, and I'll show you, if the demo gods are on my side, I will show you it actually working.
Sounds good. Would you
yes.
like to take a question?
I would love to take a question.
Okay, so we've got one here. How the multiple region impact the RUs and input throughput of Cosmos DB? Do we need to double our throughput? And our queries become automatically twice as more expensive if we're doing so? So I guess to summarize, I think the person is asking, how do multiple regions impact RU ingestion?
Okay, so this is the way it works, right? When I stand up a Cosmos DB account in a single region, and I start to build, I'll create a container. Let's say I've got a customer profile database. I create my customer profile container, and I allocated a certain number of RUs, right? Say 40,000 RUs per second, and I pay for that. Okay, if I replicate that account to a secondary region, everything is replicated over the second region, including the way that container is set up. So effectively, if I have 40,000 RUs, in region A, and I replicate it to region B, I'm going to have 40,000 RUs in region B. So it's going to double my cost effectively, and that's the way it works in terms of cost. In terms of that's the cost of running the service, if you like. In terms of the consumption of RUs, it doesn't really make any difference. There are certain scenarios in which it does, but with your query, certainly it won't make a difference because you're querying from one region. So it costs maybe 5 RUs to run a query in region A. Even if you add region B, it's still going to only cost you 5 RUs to query region A. However, the writes potentially can increase the cost because when you're writing to region A, it will write to region B. However, you're already paying for that cost in region B because you're paying for the RUs, if you see what I mean. So you won't see an increased write cost in the RU that comes back. It will, if my write of an item costs 5 RUs in one region, even if I'm multi-region, it'll still cost 5 RUs. But obviously, you're going to be consuming from that RU budget for 2 sets of writes effectively. But as I said, because of the way we make Cosmos DB work, you're already, when you stand up a second region, you're already paying for the RUs in the second region anyway. So that's where that cost is covered basically.
Well, thank you for the answer. We've got about 15 minutes left in our session today, so I will kick it back to you and let you start your demo.
Yeah, I'm gonna run very quickly through the slides that show you what's happening in the demo, and then I'm going to kick to the demo. Okay, so the key thing about the SDK, as we'll see in just a moment, is the preferred region list, right? So as I mentioned, you have to if you just create an application that talks to Cosmos DB and you don't configure that code, right, to understand the concept of multiple regions and stuff, all it's ever going to do is talk to your primary region. Okay. If that primary region fails over through a region outage, then that's okay. But it's not going to be able to deal with transient failures and stuff like that. So you do have to configure the SDK to understand the concept of other regions and to know what to do. And this is the concept of the preferred region list. And we're going to see this in like just a minute or two when I bring the code up, right? The preferred region list is across all the SDKs is how the SDK manages multiple regions and understands what to do with those regions when there's a failure. So let's take a look at just .NET as an example, right? I'm going to step you through this code very briefly, and then I'll show it to you in action. So with .NET version 3, and it does change between version 2 and version 3, and it changes in some of the other languages as well. You've got this concept of an application region. So you can see that where it says number 1, there's an application region. When I set up, when I create an options object and I set the application region, what Cosmos DB, what the SDK does is says, okay, what you're telling me is that this application is hosted in this region. In this case, it's East US. And I'm going to go off and talk to the backend and get a list of all my other regions in this account, and I'm going to order them by distance from my primary, the region you've told me I'm hosted in, right? So so it kind of creates the preferred region automatically. I've also showed a second option in this bit of code, which is where you can manually you can build a list of regions in the order that you prefer. Okay, you have that option. And just to show you that and by the way, you can see that it passes the options into the client object. And just to show that across all the SDKs, this concept exists. In the Java SDK, we also have this preferred region list, which you pass in as an option when you're creating the client. In Java, it's slightly different because you can. The only option there is to manually build this list in order of preference, right? So, and what that does is when you build it in order of preference, what it's going to do is it says, okay, I'm going to start talking to the first region in this list, and if I hit any problems at some point, I'm going to go to the next region in the list. Okay. One thing I wanted to highlight here in this slide before I cut to the demo is that in Java there's slightly more work you have to do in the Java SDK. If you have multiple write regions rather than single write regions, you also have to tell the SDK that. So I guess the key takeaway is across all the SDKs, there's this concept of preferred regions that you must set up if you want your application to behave correctly when there's a failure. But the way you do it varies slightly. It's all in the documentation, but it does vary slightly from SDK to SDK. Okay, so let's cut to the demo. I'm going to just drop out of this briefly, and I'm going to show you. Jay, could you just confirm that you can see that? Okay.
I can see everything. Let me just see it. Our audience, if you are having any issues seeing this, here it is in full screen. Let me know. We could always just stop for a second and increase the size, but I think that this is doable. I'm going to leave this in full screen while you go ahead and get started.
Yeah, and there's not a huge amount to see here. This is a piece of .NET, very, very simple. But the key thing is that I have this, I have to create a client, and I have an options object where I pass options to. That's pretty common no matter what you do. But this is the key piece of code here, right? This is the application region. I talked about it, right? I'm telling the SDK, you exist in this region, right? So go talk to the backend and find out what that means in terms of the other regions that you have out there. If I were to not do this, if I were to not set up application region or this secondary option that I have commented out, preferred regions, if I just didn't mention this at all to the SDK when I'm setting it up, what would happen is my application would happily talk to my Cosmos DB database, but it wouldn't be able to fail over to a secondary region because it wouldn't know about the secondary regions, right? Okay, so I'm going to show this in operation, right? I'm going to just demonstrate what we're talking about here. I have in the back end a Cosmos DB instance that's spread between North Europe and West Europe. The primary is in North Europe. Okay, so let's kick this demo off, and we'll see it in operation. And again, the text itself is not what's important. It's what it's doing that's important. Okay, so I'm going to move this so that you can see the log down the bottom here. You can see that it's already. It's talked to the back end, and it knows that it's got a write endpoint here, and it's got both a read and it's got two read endpoints. So this is it's chatting to the back end. Okay, so And then if I run a query, off it goes, runs the query, costs 3 RUs, doesn't take very long. And if I run the query again, and I'll show you why this is important in a minute. It runs the same query, it works, right? This is Cosmos DB just doing what it does. It's talking to its primary region and it works and everything's fine. Okay. Now I'm going to set this off again. And this time what I'm going to do is I'm going to interfere with the connection to the back end. All right. So I'll let the client kick off and imagine. So we're here, maybe we have a microservice that's sort of been set up, it's running, it's taking requests and so on. And I'm going to use this. You won't be able to see this, but I've got a little application here called Clumsy, and I'm going to tell it to start dropping a lot of packets to the main region. Okay, so it's now doing that. I'm going to kick that query off, and immediately you can see that it hasn't come back, right? Because it can't talk to the primary region at the moment. There's some kind of error, and you could imagine it could be some kind of firewall problem, or it could be some kind of network appliance failure, or who knows what's happening. But for some reason, right now, my application, let's say my microservice is not able to talk to that primary region. And it takes a while for it to decide what to do. And you can hopefully see in the logging here, there's a whole bunch of stuff going on where it's querying the database, finding where its other regions are. And finally, what it does is you can see is it's now completed the request. But I don't know if you can see this, but you can see that the read endpoints here, it's now put West Europe as the primary read endpoint. Because what the SDK has discovered is that North Europe isn't working anymore. And so now it's going to favor West Europe as its read endpoint. And what that means is if I run the query again, it comes back immediately, right? Because the SDK has discovered that where it was reading from before doesn't work. And so it's consulted its preferred region list. It's checked the other region is working. And so it issues the read off to that other region. And then for the lifetime of this client instance, it's now going to keep talking to that region, right? So if you imagine, like if you were in a customer facing application, what you see is that you in the event of a problem with that primary region or accessing that primary region, you're going to see some latency here, right? Because for that first operation that is struggling to reach the endpoint, it retries a number of times, right? It retries a number of times, finally decides it can't access that endpoint, and then flips over to the secondary region. But that means you're going to get some latency there in that for that particular operation. But then after that, everything is back to normal. Okay, and kind of that's it really for the demo. So I'll just go briefly back to the slides just to I know we've not got much time, but I wanted to just highlight kind of like the key takeaways that they always expect exceptions, right? In these cloud applications, you need to expect that these things are going to happen sometimes, and you need to know what to do about it. Watch for higher latencies because they're an indication that the SDK is having to manage some transient failures in the back end potentially. And the biggest one is always monitor your telemetry, right? Because that will tell you when you've had a problem, how the SDKs have managed to deal with it, and it will allow you to then take the appropriate steps as necessary. And with that, Jay, I'm done.
Wonderful. Well, thank you so much. That was all really interesting, David. And I learned a lot more about high availability and how it works along with applications. If you're watching on YouTube, you can go ahead. You can see all the links that we've shared today. And that's really it. I know, Kaylee, you had a slide here for Q&A. So I'm going to go ahead and bring that up. If anybody has any questions, we'll take a few minutes and answer them. If not, I think we'll be ready to close up. All right. So far, no questions. We'll just give it another minute. But Kaylee, any more interesting Reactor sessions that you can share with us coming up?
Yeah, so I will, if you can go ahead and post the our Redmond Reactor page, you can definitely find more upcoming sessions there.
Here you go. Here's the Reactor. There's the link for the Reactor in our comments. Looks like we don't have any questions. So I think that gives us a good opportunity to go ahead and wind down. David, thank you so much for being part. Kaylee, any closing notes for you?
Nope, none for me.
Fair enough. Well, with that, I will turn on the closing music. There we go. And thank you all for watching today. David, thank you so much for all the great information today. If people want to get in touch with you, what's the best way they can do so?
Well, it kind of depends, really. I mean, basically, we're here to help any customer that needs any help with Azure Cosmos DB. So I would, in the first instance, reach out to your usual Microsoft contact, ask to speak to myself or one of our other GVPs, and we'd be happy to help.
Wonderful. Well, thank you so much, David. Until next time, everybody, we'll be back next month. We've got another session planned for January. You can come and be part, just like you were this week. And, the easiest way to actually join us here and be one of our presenters is to go ahead and fill out our intake form. Literally, that's what David did. He filled out our intake form. We worked out what we were going to talk about, and here we are. Anyhow, yeah. So that's that. Anyway, I just want to say goodbye. Thank you so much for watching, and we're looking forward to see you at the next one. Have a great holiday season and a great rest of your week. Take care, everybody. Bye now.
Thanks, everyone. Bye-bye.